So this worksheet is just a continuation of what we did yesterday. So you should understand every little piece. You need to understand the difference between recursive and explicit. You guys know that. But I do want to go to number 24. Okay. Oh, it's right there. Great. Look at that. So for number 24, it's similar to a problem we did a while ago. Let's look at this in an arithmetic sequence. So imagine that we're adding the same number every time. And I tell you, on day 5, you have 20 bucks. And then on day 10, you have, geez, I don't know, make this up, $180. How are we going to find out the common rate, or sorry, the common difference if we were adding? So what's happening is a sub 5 is 20, and then I'm going to add D, and add D, and add D. How many times am I going to add D? 5 times. And when I get done, that equals 180. So what I need is the total difference. How far is it from here to here? Well, it's $160, and it's also 5 Ds. So I'm going to divide this by 5. Oh, how nice. It turned out to be a good number. Divided by 5. So my D would be $32 each day, or second or minute, whatever it was. Okay? So the same basic thing is happening in number 24. We have a sub 2 equals 12, and then we're going to do something to it how many times? 3 times, and that ends up equaling a sub 5, which is 768. So I'm looking for a common ratio R. What do I know about R before I solve anything? So my a sub n values are going up. How do you make a sub n values go up using R? Well, my R has to be bigger than 1. If my R was 1, what would happen to my a sub n values? No, it would remain unchanged. It would stay itself all the time. Okay? What if my R was less than 1? Then it would be shrinking. Okay? So, how far did I travel? Wait a minute. It's not 756. Right? We're not adding every time. We're multiplying every time. So 768 divided by 12, what does that number mean? So over the course of 3 n's, I increase 64 times. So if I divide that by 3, now I get 2133. So in theory, I should be able to do 12 times the answer times the answer times the answer. And Alexa is freaking out right now. It didn't work. I've been turned into a cow. Can I go home? You may be excused. Anyone else? Nah, we're good. Okay, why didn't that work? I didn't lie to you. You guys made the mistake. Nope, Alexa, don't say it yet. Well, let's think about it. So, if this jump was 64, right? But instead of doing one jump, how many jumps did we do? So we did this, this, and that. Each one of those jumps is an R. Anybody see it yet? What's wrong? Nope. The R has to be the same every time. Right. So in one jump, we got 64. In three jumps, we get r to the third. So r to the third equals 64. So when you divide a multiplication into three groups, we're not splitting it using division. We're splitting it using exponents, right? This is an exponential geometric situation. So each jump is an exponent, not an addition. So the common mistake here is a lot of people come up with 64 and they say, okay, we're going to divide 64 into three equal groups, which is true, but you don't do that dividing using division. So we need to take the third root of 64, which is 4. So 12 times 4 times 4 times 4 is 768. Okay? And that's a really common mistake for people to make, is to treat it exponential for half the problem and then treat it as linear for the second half. And that doesn't work. Yes.